In this tutorial, we're going to take a look at implicit differentiation. And implicit differentiation happens when you take the derivative of a function that is not with the respect of the variable that you really want it to be in, at least not the whole thing. So let's take a look at an example. We're going to take a look at a function y equals 3x plus 6. And I want to take the derivative of this function. Now I'm going to use Leibniz notation, and I'm just going to get this set up so that you know that we're taking the derivative. So on the left-hand side, I'm going to say dx of y, dx means derivative, equals dx of 3x plus dx of 6. Okay, so on the left-hand side, what you need to notice is that this derivative was being with respect to x, and I'm taking the derivative of a function that is not. This is a y term, and that is a problem. But we have a way of getting around that. And the way that we do that is we go ahead and we take the derivative of whatever this guy is, pretending like that's what we're taking with respect to. So the derivative of y would be 1. So I'm going to write 1 here. And then I'm going to multiply it by something else. Now, you know that this ddx part represents the derivative with respect to x. But I need to tell my audience that I am taking the derivative of something else without being respect to x. So I take my variable, whatever it is, and I put it in the numerator with the other d. So 1 comes from the derivative of y, and dy dx comes from me telling the audience what I'm taking the derivative of and with respect to. Now, on the other side, we are taking the derivative with respect to x of 3x. And since those are in the same term, I can just differentiate as normal. So the derivative of 3x is 3. And then over here to the right, ddx of 6, well, the derivative of any constant is 0. So I'm going to take a look at this because what I want to solve for is dy dx. So 1 times dy dx is very simply dy dx, and it's equal to 3, and that is my solution. That's what I want it to look like. Now let's take a look at another example. Okay, so here we are. It says find dy dx for this function. And before you start thinking that this is super difficult, it's really not. The parts that will need implicit differentiation are all the y terms, so here, here, and here. But we're going to take this one step at a time, and I'm going to write this out using Leibniz notation first. So I'm going to do d dx of y cubed plus d dx of y squared minus d dx of 5y minus d dx of x squared, and lastly d dx of negative 4. Okay, that was a lot. So we're going to take this one piece at a time. So this first term, I'm taking the derivative of a y term when I'm taking this with respect to x. So I'm first going to take the derivative of this piece as if it were in terms of y. So the derivative of y cubed would be 3y squared. Now, because I'm not taking this with respect to y, and to let the audience know that I'm taking this with dy dx. So this is in terms of y, but I'm taking the derivative with respect to x. Alright, so there's the first part. Plus, now, what is the derivative of y squared? Well, that would just be 2y, but I need to add on a dy dx. Now I have to do the derivative of 5y, which is just 5, but it's with a y, so I need to add on a dy dx. and I get to a part where I am in terms of x. The derivative of x squared is simply 2x, and I don't have to add anything onto it, which is really nice. And then the derivative of constant is 0. Now, I have to get this so that the dy dx's are all alone. What I'm first going to do is I'm going to add 2x to both sides, because that does not have a dy dx term in it. All right, so those are going to cancel, and I'm going to be left with 2x. Now, I want you to notice over here that I have a dy dx present in every single term. So I'm going to factor that out, since that's what I want to solve for. So dy dx, and I'm going to open up a parenthesis, and I'm going to write down everything that I'm going to multiply it by. So let's take a look at this first term here. What do I multiply dy dx by to get this entire term? Well, that would be 3y squared. And the next piece, 2y times dy dx, so I'm going to have to multiply this by, add this to 2y, and then minus 5. Now, there's only one last thing for me to do to solve for dy dx. dy dx is being multiplied by this entire expression. So in order to solve for dy dx, all I have to do is divide both sides by this expression. So that's going to look pretty ugly. It's going to be 2x divided by this whole thing. So 3y squared plus 2y minus 5. And as ugly as that may seem, this is my final answer. This is how implicit differentiation works. And that concludes this tutorial.